I'm Michael Asbury. I am the founder of Elevate Coaching and Consulting. I'm a certified Lean Six Sigma Master Black Belt and Theory of Constraints Jonah. And today we're going to be going over how you can make a strong comeback with Theory of Constraints combined with Lean Six Sigma, which is TLS. All right. So we are going to be hosting a training series coming up if anybody is interested. And I will be sending you the PowerPoint presentation that I'm using today. And if anyone is interested in training, you can email me and I can get you the links to sign up for training. So in a typical business, and this is very oversimplified, as time increases, sales is going up. So this is through inflation plus increasing volume, adding additional product lines, etc. But at the same time, typically expenses are going up as well. So this means we're adding people, we're adding equipment, we're expanding, as well as inflation. And when you subtract the expenses from the sales, the difference between those two is the profit. Okay, very simple. So our objective is to increase our profitability continuously. So at some point in time, we decide we want to focus improvement efforts on increasing our sales and decreasing the expenses relative to those sales. So we want to get more through our existing resources. At the same time, we're using less inventory, less overtime, less scrap and rework. And if we do that, our profit margins will increase. Okay. So what happened when the pandemic hit us? It made a pretty big impact on the economy, right? For a lot of companies, they may have had a backlog of sales that continued for a little bit. And then as companies realized how the pandemic was going to impact them, a lot of orders have been canceled or postponed. So demand dropped off dramatically and very rapidly. For some companies, it went to zero very quickly. For others, demand stayed constant and some had even increased. And for the companies that did have a decrease in demand, as that started to happen, they tried to look at what they could do to decrease expenses. But for a lot of them, the fundamental overhead that they have in terms of buildings and salaries and benefits and things of that nature is actually higher than what's covered by the current sales. So when that happened, the profit for a lot of companies decreased, but it even went negative for a lot during this period. So while this is going on, we have everybody in the company trying to fight problems in all different directions. And by using TLS, we want to get everybody going the same direction and with a very aligned and very powerful effect. Okay. So remember where we left off in the previous diagram. What we want to do in order to make a strong comeback is revitalize the flow by applying TLS. So first we want to stabilize, then we want to enhance and increase the flow. So in order to do this, we need to assess, plan, and execute in three different dimensions in terms of our demand, our supply, and our capacities. So this is where we left off from the previous diagram. And we have the difference between our sales and expenses before the pandemic with this level of profit. And then once the pandemic hit, for most companies, it's less than it was before. And in some cases, it's even negative. Okay. In a lot of cases right now. So we want to drive some focused improvement efforts now that allow us to decrease some of the defects and downtime and overtime and things that we're facing right now. And at the same time, find some customers that we can actually increase orders with. And if we do that, we want to be able to get back to a level of profitability that we were before, even if we are at a lower volume. And then as the economy starts to reopen and we've made some adjustments. We want to start coordinating with additional customers and continue to increase our sales demand. And at the same time we're doing that, we may be bringing back some resources that we have temporarily put on hold. We want to make sure that that red line stays below the green line so that we can maintain our level of profitability. Then we're ready to go into the next phase where we basically we're applying our focused improvements with the additional resources that we had back in these days, and we want to continue to drive up our sales volume without ramping our expenses all the way back up to where they were. And if we can do this effectively, we can end up at a higher level of sales than we were before with a lower level of expenses than we were before. So we can end up with a lot higher profitability. Okay. So I held another webinar on the basics of theory of constraints plus Lean Six Sigma. And I'm going to make that available on demand as a video on my website shortly. I just need to edit the video a little bit before I post it. Okay. So the theory of constraints was introduced back in the early to mid 80s by Dr. Eliyahu Goldratt and Jeff Cox in the book The Goal. So from theory of constraints, we talk about, first of all, we need to know what the goal is of an organization. Then we need to know what do we need to change in order to be better at reaching that goal. Then what do we need to change to, and how do we cause that change to happen? Okay. So when we're talking about constraints, you need to think of an organization as a system. And any system is composed of a series of processes. So the system flow is limited by a single or limited number of components or resources that have less capacity for flow than the others. So you can imagine it like this. We can put more inputs into a system than can come out. And how much can come out is determined by the constraints within the system. So let's take this example. So what we've got here is a freeway back here with 3 lanes where we can go 75 miles per hour. Then it narrows down to a 45-mile-per-hour 2-lane bridge, and then it narrows on down to a 30-mile-per-hour tunnel. Okay. So with a low amount of traffic, things flow through pretty easily. It might slow down a little bit as it goes through the tunnel, but it doesn't have too much of an impact. Okay. So we have plenty of capacity for low flow. Then as the demand increases, flow starts to increase in the system. Then we start to see some interesting effects. So we're able to travel at the full speed limit here through the tunnel, 30 miles per hour. But if these drivers are kind enough to allow traffic to merge, back here they can only go about 15 miles per hour. And back here, they can only go 10 miles per hour. So 10 miles per hour, what happened to my productivity? The supervisor's saying. And what can you imagine would be happening in a company where this department, they're operating at 100% productivity. These guys are at 50% productivity, and these guys are at 33% productivity, and they've got the most people and equipment back here. What is the management going to do to try to improve this situation? Well, their metrics are telling them that these guys are operating pretty well, right? But these guys are operating pretty poorly as far as their efficiency and productivity goes. So what you might end up with is the directors and the vice presidents of the companies recommending that we build some type of an off-ramp here and some type of a parking garage so these guys can stay active, right? We're going to do some major capital project so that we can improve their productivity, and ignoring how many units we can actually get through the tunnel. Okay. So what a lot of organizations miss here is that the bottleneck controls the flow rate. We don't get it through to the other side of the tunnel, the cash register is not ringing, right? Okay. So how many of you have heard of Murphy's Law? That's where if something can go wrong, it will go wrong. So what happens if suddenly flow stops here at the constraint? Oops, forgot to put gas in, right? So they're not going anywhere. They can't go anywhere either. Likewise, back here they can't go anywhere, and that's not cool. So we're getting nowhere fast. This isn't efficient or effective. So it's important to remember that if the bottleneck flow stops, the system flow stops. If we keep running here, we're just going to build up a pile up at the bottom of this ravine, right? Have a big problem. So now let's briefly talk about what it's like when we combine theory of constraints with Lean Six Sigma. Think of it like we're driving rapid improvement with the scientific and intuitive sequencing of our improvements. So from the theory of constraints, we get identifying and defining our goals. It's very constraint focused. It also has buffer management. There's strategic planning, and it's throughput driven. With Lean, customer value drives the focus. And it's also very focused on identifying and eliminating waste. And it has tools for that. It's also very heavy on engaging employees at a high level and producing product and services based on what the customers are actually purchasing. So matching the rate that customers are purchasing with how much we're producing. With Six Sigma, it's data driven. There's a structured problem solving approach. It's team oriented, and they have variation identification and reduction tools, and it's focused on improving the effectiveness and the efficiency of processes to increase the flow of value to the customers. So when we combine them, we've got a goal driven, focused, collaborative, data driven, obstacle removing, and value increasing methodology. So the tools available to us by this with this combined methodology are the ones from Lean. We've got about 20 here. The ones from Theory of Constraints, we've got about another dozen. And then we've got about 150 from Six Sigma. Okay. So with some training, you can figure out what's the right sequence and combination of these to make the most impact with the least amount of effort. Okay. So Bob Sprawl developed the ultimate improvement cycle back in sometime in the early 2000s and published a book called The Ultimate Improvement Cycle in 2010 or 2011, I believe. So at the center of the ultimate improvement cycle, we have the theory of constraints. So we have identified the constraint, exploit the constraint, which means get as much out of your bottlenecks as you can. Then we subordinate our non-constraints to how we are getting the most out of our constraint. So this means coordinating our non-bottlenecks. And then if necessary, we add capacity at our bottleneck. Okay. And then we repeat, okay, is the bottleneck still the bottleneck or has it moved? Then with Lean, we have identifying value, making value flow by removing waste, and producing to what the customer is the same rate that the customer is purchasing. And then pursue perfection. With Six Sigma, we have identify, define, measure, and analyze, improve, and control. And so this is what the ultimate improvement cycle is. These are some highly recommended books that I've used to study this. And you can purchase them all on Amazon on Bob Sprawl's author page here. So with as we go through the cycle, we start by getting a complete picture of the system in terms of flow and predicted people behavior because of the metrics, and we only start to measure efficiency at the constraint. Then we have a knowledge of the location and the type of waste and inventory, and plus the potential system core problems. Then we have a knowledge of the location and type of variation and defects in the system. Then we create a coherent action plan on how to improve our system capacity. Then we execute that and we have a well-organized constraint with minimal waste. Then we have a well-controlled constraint with only common cause variation. And at this point, we develop a coherent and documented plan on how do we synchronize the rest of the system with the capacity and flow through the constraint. Then we have a well-functioning process with synchronized flow. Then we optimize our safety buffers and the work in process is minimized throughout the system. And then we develop a coherent sustainment plan and optimize the process capabilities and control. Then we have a complete understanding of our new system flow and capacities and our financial gains using throughput accounting. Then we develop our sustainment actions and get them in place and functioning well with sound financial decisions. Okay. So an organization has a lot of processes in it. So it's very important to figure out what is the best sequence to um, to prioritize your improvements in order to have the most impact. So consider the following piping diagram and imagine that there's liquid gold flowing through this. Where would you focus your improvements first and second to get them to increase the flow through the system? You would start with D, right? Because it has the most constricted flow. So if we started improving in A, all we did was spend time and money and effort, but we didn't get anything else out the other end. We actually probably just increased our work in process and added more pressure at B, D, and F, right? So if we want to get more flow through here, we want to get more flowing through D first, right? Then F, and then B. If we follow that sequence, it gets us the best impact by a factor of 10 at least. So we need to keep this in mind when we're selecting our projects. That's where a lot of improvement methodologies and Lean and Six Sigma transformations fail, is by getting the sequence out of order. Okay. So once we know the sequence of the different areas of our organization that we want to focus on, that's when we start to talk about the food waka. And I'll explain what that means. It's not one of those lean Japanese terms, but this helps us to identify the symptoms and obstacles of our system. So we go and start to talk to the subject matter experts in the areas where we're going to have our targeted improvements. And those subject matter experts are the leadership and management and the employees in those areas. And we're going to ask them what makes them feel frustrated, upset, disappointed, worried, angry, concerned, and anxious, because those feelings are relative to the things that are keeping us from increasing the flow. Most people, when they're at work, they want to do a good job and get a lot of stuff done with the least amount of effort, because they want to bring value to the organization and they want to be recognized for that value. So these things that are making them feel like this are red flags as to what the problems are to the flow. So then we create a high level process map of the organization. So typically that starts with marketing, sales, a customer agreeing to make a purchase, order entry, adding the order to the queue, basically scheduling it. Then we purchase our materials. The supply chain does its thing. We receive the materials and put them away. Then we stage them and the info to wherever the processes are that they need them once they come up in the schedule. Then we do our step 1, 2, 3, 4, and 5. Whether we're performing a service or we're producing a product, there's typically 5 to 7 big phases that we go through. Then we finalize it and we deliver the product or service to the customer, which means it may go through logistics and distribution. And then finally, we send the bill and deposit the check. Okay. So where in our system is the constraint? That's important to know. I mean, when we were talking about a little piping diagram, it was pretty obvious to figure out where to look, right? But when we're talking about an organization, it's not that simple, is it? So some clues that we can look at are which process has the longest cycle times, where's the most work in process at waiting to go through a process, who works the most hours, such as weekends and overtime when other areas are not. And you can also look at where's the most rework occurring because it may be slowing down a process. But in order to solve it, you may need to go to the process that actually caused the rework. And that's a good place to apply the 5 whys for root cause analysis. Okay. So, in addition to knowing what part of the organization we need to improve in order to increase our throughput, we also need to think about how the product mix works. Which product families would have the most potential to increase our profit if we could get more of them through the organization? So we can make a list of all the product families and all the main process steps, and then put an X in the box for which processes go through, which product families go through which process. Okay. So in this example, you can see that all the product families go through step one. Half of them go through six, half of them go through seven, and once again, they all go through eight. Okay. You can also make a simple model of how your product families flow through your processes. So if we have the processes listed across the top and we have our product lines across um, down down on the left here, we might choose which process flows through which is which which product family is routed through which processes. Okay, so let's say we decide we're going to make the most profit if we can improve these 3 product lines. Okay, they're our top priority. Well, the good thing is that some of the process steps are shared with the rest of our product families too. So if we improve those processes, other product families will also benefit and um, increase their throughput. Okay. So another thing we can look at here is a value stream map. In this, we are creating basically a model of how the information in the materials or parts flow through our system. Okay. So by doing this, we can create a red flag of some areas that we should start our improvements on, such as looking at the amount of inventory waiting to go through a process, looking at the cycle time, looking at changeover times, looking at how much downtime there is, which is up one minus uptime. So we noticed that if we want to start improving this organization, we really need to deal with process too. But by having this information, we also noticed that if we improve that by more than 6 minutes, our bottleneck has moved over to process three, and it also has long changeover times compared to these other processes. And it also has a lot of downtime. Okay. And then we also noticed that um, the production schedule is scheduling each one of these processes independently. So that means each of them is probably working on their efficiency and their productivity and not as concerned about the big picture of the whole organization and which orders are on time and so on. So that leads to local optimization, which may be good for one area, but may not be good for another area. So next we get to data collection. Um, Deming said, "In God we trust, but all others must bring data." So this means we need to get the facts if we want to solve the puzzle. So now we take a closer look. We figured out which product families we want to deal with. We figured out which areas of the company and which processes we want to improve. Now it's time to take a closer look. So we do a time value analysis of a department where we need to look deeper. So the green are value added activities, the yellow are business value adding activities, which means the customer is not necessarily willing to pay for it, but because of the way we're set up, we have to do that step in order to do the value adding step. And then the red ones are non value added. Okay. So consider these stations have these steps that took this amount of time, okay? And these white diagonal lines are the time waiting in between these processes. So when we were done with one unit, it sat there and wasn't worked on until this station was ready for it to begin again, okay? So if we look at it like this, we can see that within the department process time, when they were actually working on it, about 60% of the time that they worked on it, it was value adding, and 31% was non-value adding, and 9% they needed to work on it. But if we look at the entire time that unit was in the department, we look at it this way, okay? So this gives us an idea of how it's flowing through the entire department and some of the wastes. Then we can drill in even further and look at a particular station process within a department and look at it for a period of time and see how much it's varying, as well as the different waste that happen during different cycles and different periods throughout the day. Okay. By doing this, it gives us a um, really good quantified data for what's going wrong, what's slowing them down, and how much that impact is happening, and how often it's happening. Okay. So another good way to look at um, your bottleneck is to figure out how much can we actually possibly get through that thing. So you start with how much time available does it have, and how much can it handle per unit time. So the first thing we lose is downtime if it's not functioning right. If you're an engineer and your computer isn't working, or your software is not working, or the internet's not working, then you can't do your job. Likewise, if you're an operator on a machine and power's out or there's something wrong with it, that's the first dimension you lose. Then we have time that we waste during our cycles and between our cycles. Then we have load waste. So this is where maybe we could do two things at a time. You know, maybe we could bake two cakes at a time in the oven, but we're only baking, you know, a very small cake that only fits on, you know, a third of one of the racks, and we have three racks in the oven. Okay. So that would be loading waste. And then we have yield waste, which is we have put something through more than one time, so it doesn't count except for the first time. So we went from that giant rectangle all the way down to this amount that we're actually using. So you can look at utilization as uptime times time performance times load performance times yield. Okay. You don't want to use this at non-constraints because you just want the non-constraints to flow at the pace that your constraint is flowing. So you wouldn't do time performance and load performance. You might replace that part of the equation with um, on time to the constraint or on time to shipping if it's after the constraint in your processes. So let's look at an example here. Let's say we had 90% uptime, 85% time performance, 85% load performance, and 90% quality yield. So if this were a report card, that'd be pretty respectable, right? It's not straight A's, but it's pretty solid. Well, since these are compounding, we actually are at more like 58% of utilization of that resource. So this helps us to know what types of projects we may work on to get more through our constraint. Okay. And we may measure the throughput through that constraint and measure those things that are affecting those four dimensions as the issues here that are happening during that time period. And then we might break those down with the Pareto chart and have the subject matter experts work on have them look at this and say, well, these are the top issues we had this week, and these are what we think are the root causes, and this is what we're going to do about it, who's going to do it, and by when. Okay. So now I'm going to introduce you to the chain of solutions. This is something that I developed when I was the corporate continuous improvement manager for 24 facilities around the country. And I had a team of 3 people working with me. So we had very limited bandwidth, and we had to be very strategic about which projects we worked on to make the most impact for the company. Okay. So imagine that these are all the processes we have throughout the organization. And imagine that these are the cycle times for how long it takes to process a unit through each of those. So this helps us to prioritize which one we should um, prioritize our improvement projects in first, right? So first we would go here because that's a constraint. It takes longer to get through there than anywhere else. But we realized that depending on how much we improve it, soon it will be there, and then soon it will be there. So this helps us to realize, with an improvement project, we may be able to improve something from 20 to 50%. We would easily be down in this range. Okay. So by knowing this, that helps us determine how far we need to go before we need to shift our focus to another area and coordinate it. So once we know this, then we can talk to the subject matter experts and find out what are the obstacles for each of these processes. So imagine that you have a flip chart and basically you called in the subject matter experts for process A, and they told you these are the things that are wrong with A. Then you held another meeting, with each of these groups, and these are post-it notes, and you identified those obstacles and ranked them from high to low for what are their biggest problems for each process. Then we measured the value and waste of each of these processes. So there's our value time, there's our business value add time, and there's our wasted time. Then we may need to reprioritize these slightly because we did this based on memory. Okay. So then we identify and rank our solutions that would cancel out these obstacles. So imagine this is another color of post-it note that matches up with this. Okay. Now imagine that we want to increase our throughput or increase our profitability by 20%. So for that first round of 20% improvement, we may realize that if we do these 4 things at C, these 3 things at D, and these 3 things at P, then that can drive 20% of improvement in our organization. Okay. The good thing is we've done this analysis. We have all of these things we could do. Now it's a matter of figuring out when's the right time. So let's say we want 20% more improvement. Well, now we realize, well, we need to do 2 things here, do another thing at C and D, and we can make a couple of improvements at M and N, another improvement at P, and then a couple at Y, and then we're at a whole nother 20% better than we were on top of that 20%. Now if we want to keep going, we can keep going. So let's say we want 10% more. Okay. So that's how you can use the chain of solutions to help prioritize your improvement projects in your strategic improvement portfolio. Okay. So if you do that, you can go from initial baseline that looks something like this to an improved state that looks something like this. And some of you that are very observant might say, well, why do we still have a big wait time here? And that's because we implemented drum buffer rope. This was our constraint, and we wanted to make sure that this station always had something for them to work on because we don't want to lose any of their capacity. But as the system gets better, we can continue to decrease this amount of time as well. Okay. So now we were primarily looking inside your organization with those first steps. Now, you can also create a roadmap to efficacy, which means you're getting the results that you were, that your system is set up for, right? So first you assess the system. Where are you at? Stabilize it, which is like decontaminating before you open the floodgates. Then you improve the constraints, increase your flow, and reassess because things may have changed since this first assessment. Then we strengthen and coordinate internally as well as with our supply chain, do next level analysis based on what are we good at and what does the market need. Then we can expand our offerings so that we can even get more throughput with less cost per unit through our existing resources. Plus, we might have additional products or services we can offer that match our capacities and capabilities, and then we can move into a scalable growth phase. Okay, so I want you to think about that the same process we talked about, but applying it with our value chain partners. Okay, so let's consider this our organization, and we realized we needed to improve that link first, but we have these suppliers that could have some issues, and we have other distribution channels that could have issues as well. And the suppliers could have suppliers with problems, and our distribution channels could have issues with further on down the value chain as well. So recall this pipeline, right? When we talked about how to prioritize our projects. Well, now think of it like this throughout our value chain. We realize we can make an impact with what's in our span of control by focusing here to get 20% better, and then here. But by the time we get to there, we might be putting more demand than they can handle in the supply chain. So we might need to help coordinate with them so that they can make an improvement so that they can support our higher level of flow, right? So imagine each one of these phases like 20% improvement, okay? So by the time we get to this increased volume, we might have had to touch all these different areas in our value chain to keep up with our growth. So one way that you could sequence that is by thinking of it like this is time and this is the effectiveness of the organization in terms of dollars. So we may start out by doing some strategic improvements internally that drive us up by 20%. Then we may need to go into a phase where internally we're doing continuous improvement while with our value chain partners, we're doing strategic rapid improvements. So our value chain partners may be going through a phase of strategic improvement while we're in a continuous improvement mode so that they can keep up with how much increased volume we're handling. Then we can go through another phase internally. Then we probably need to check out our value chain again. And then so on. By the time we go through the third strategic improvement project phase, we're probably beyond the limit of the traditional performance levels in our industry. Probably become a leader by the time we get there. Okay, so by doing that, we've effectively done this, where we've increased our volume while we've decreased our expenses relative to that volume, and we've increased our profit. Okay, so first we assess our current state, and we go through a rapid improvement project phase. Then we start to get that ingrained with the culture by coaching and setting up change management and training so that it's not just a strategic improvement project team that's doing all the improvements. More people throughout the organization are understanding. They've seen how to do it. They've seen the results that can happen, and now they're being taught on how to do it. Then we're coordinating and helping our value chain partners do the same thing that we've been doing internally. And then finally, we're achieving a new level of value chain excellence. Okay, the benefits of this are the customers are more satisfied. They've got better on-time delivery, better lead time, better quality. The internal company benefits are that we've got increased throughput, which means more sales. At the same time, our inventory has come down. We have less work in process. We're having better higher inventory turns, which means better cash flow. Our operating expenses are coming down, so we have less material waste, less rework, less overtime, less turnover. And the employees are more satisfied because they were involved in this whole process. They've got a better understanding of how everything fits together in the organization, as well as how their part of the world fits in. They can do their work with less effort and frustration. They're more effective. They've got more confidence and pride because they made it better. And there's an increased potential for them to have higher job security and better benefits and increased pay because the company has more that it can actually share with them. Okay. And even the suppliers and the distribution channels benefit because they can now get more through them. So they're probably making more money and have better benefits and better employee satisfaction as well. Okay. So I'm going to take the last part of this webinar to share a case study with you. So this is a large fleet project from the work truck industry. So this is a really high volume in a very short period with unprecedented results. So we use TLS in order to achieve these results. So the situation was we got a request for proposal with a new customer, which was a big fish customer that we've been chasing for a few years. And with about 3 days before the proposal was due, they said that they had a over 3,500 unit fleet that needed to be produced within a 12-week period once the chassis were available from Ford and GM. So we had two different manufacturers in different cities, and our current fleet capacity was booked up for the next 6 months. So we had zero capacity to take on this project. So we had to set up and staff 3 different facilities near these cities in order to do this. So this is what our model looked like: 3,500 vehicles, about 60% from the one OEM and about 40% from another. And we had a facility near the city, and we had 2 facilities within proximity to that one. And then once they were done upfitting these vehicles, they needed to go back to the OEM to get in the rail system to get distributed throughout the country. Okay. We had about 250 SKUs on these vehicles from about 25 suppliers. And so we had to coordinate getting those to these upfit centers. And we used some elements of DDMRP buffer management in order to control that and make sure we had what we needed. And we had to control the inbound trucking logistics, the outbound trucking logistics. And then from there, it went to about 40 secondary upfitters because not all of the fully assembled parts and systems that were going on these vehicles could fit within the train car because some of it's mounted on top. Okay. So we had secondary upfitters that had to do the final installation after the rail system. And then from there, these vehicles were shipped out to about 120 different garages for the end customer. And we found that we had a quality problem with one of these secondary upfitters that was affecting a certain region. Okay. So this is how the project was broken down with this methodology. The blue are elements from the theory of constraints. Green is from lean, and the purplish pinkish color here is from Six Sigma. So we used critical chain project management to oversee the entire project. And so the launch phase, we did one critical chain. Then we did a second critical chain project management for field quality recovery with that secondary upfitter. Okay. So during the first part of this product launch, we did DEMODOV, which is a Six Sigma methodology for setting up new products and processes. Okay, so then we went into a DMAIC process improvement phase, and we did 3 rounds of that for 3 different improvement projects. And the phases of DMAIC are define, measure, analyze, improve, and control. Very similar to DEMODOV, except you have define, measure, analyze, design, optimize, and validate. Then we did another DMAIC project for the quality repairs in the field. So first we did a concept build where we got the voice of the customer, which is the features and the specs and the timing and the volume and the delivery. Then we did the voice of the process, where we did time studies and analyzed the bill of materials. We checked for sequence dependencies, and we set up the tools and infrastructure we needed and looked for improvement opportunities by doing the time value analysis. Then we got into the prototype and pilot builds, where we studied design for manufacturability, and we got the infrastructure and stations designed. We set up Kanban with the supplier, and we also developed the DDMRP materials buffer management system. And we also set up the production so that It was very efficient and used visual buffer management. And we used training within industry for our standard work and for the 5S and applied templates, because all of the workers that we hired here were fresh and untrained. So we had to make it very simple for them to be trained and be consistent with their quality. So then we had to hire everyone, cross train them, and we set up a special batch clocking mechanism so that each person did not have to clock on and off every single vehicle, because otherwise we would have a bottleneck at the time clock. Okay. And we also implemented quality at the source and developed a QC app and dashboard. So once we launched into production, we had some decal defects from one of our subcontractors, and we had to do an improvement project on that so that we'd have 100% quality. Then we did time studies and identified constraints and did a little bit of line balancing to improve our performance yet again. And then one of the interns that I hired did a project on subassembly 5S and line balancing. And then once we got into the field repair period, we went through and defined and measured our defects and used defect maps to know what are the defects, how often are they happening, and where are they happening, so we know for each unit exactly what needs to be fixed, and we could look at the root cause analysis and verify our solutions. And then finally, we implemented our solutions and used plan, do, check, act. Okay. So our keys to success here was that the concept build. So that gave us a chance to validate the voice of the customer, perform time studies, and design for manufacturability. It was very critical also that we followed critical chain project management with a buffered schedule. And this helped within that, we got infrastructure approval and implementation fast-tracked. We had to lease a building, we had to build a ramp, we had to purchase a crane, and all of that had to happen quickly. We scheduled our suppliers 2 weeks ahead of production because we had product coming in from 4 different continents. And this allowed us to know that if it was late by, oh, and we also had them hold 1 week of buffer because I anticipated we'd improve by at least 20% within the first 4 to 5 weeks. And that would allow them to go ahead and ship it to us. Okay, then we scheduled production 1 week ahead of our shipping schedule. So if we had any problems, we could still ship on time. We staggered the launch at each facility so we could get the employees trained. And with the prototype and pilot builds, we validated the design, the bill of materials, and supplier quality. For quality, we implemented quality at the source where each station checked their own work as well as the previous station, so that by the time it got to final inspection, there were only a few key things to check, and it was a kind of a second pass. We also developed a QC app and dashboard that they could use with tablets out on the shop floor. And we used defect mapping for anything that they did find wrong. We would know what the type of defect was and where it was at. And this bulk clocking method was very critical because we were able to get 1 or 2 more trucks done per day because people were not standing in line at time clocks. So some additional keys to success were we developed high performance team with 5S for visual management, so it's very easy to train people on new stations. We also had standard work with following the training within industry format. So this made it easy. There are pictures and all, you could see what the important steps were and why they were important. We used templates to mistake proof and make it easy to train. And we cross-trained people in staggered shifts so that we could pick up lunches and break time at any constraints that we're developing throughout the day. And we used an ABC plan, meaning each person knew that they worked until their buffer was full, and then that's their A game. And plan B was they work until the next buffer was full within their station. And then their C plan was they help the next station either upstream or downstream from them until that buffer was full. And at any time their buffer came down, they would go back to A. Then we got into design for manufacturability, making sure subassemblies fit well, hardware was correct, and wiring harnesses were color coded and had mistake proof connections. We converted holes to slots and came up with forgiving tolerances that could still accomplish our design intent. And with buffer management, we set up supply chain DDMRP and a daily snapshot so that materials handlers could look for things that um, were um, had early warning signs, and they would only have to check on about 10 things a day instead of all 250 SKUs every day. So we did that with our chassis, our materials, our subassemblies, and our line workflow. Okay. So the results that we achieved were our baseline fleet metrics, our defects per unit were 0.2 defects per unit. With this project, it was 0.02. So 10 times less defects. Our on-time delivery was typically around 40%. And for this project, it was 98%. Our labor efficiency historically was about 98%. So, um, but for this project, it was 225%. Our overtime typically was around 20%. It was 0 for this. And basically, we also did something that was unprecedented. We brought in a $30 million project without even having any capacity in place when we signed the contract. And we avoided over $1 million just in labor cost avoidance because there were about 50 people that we didn't need to hire because we set up our line so efficiently. And one additional perk was we got about another 1,000 unit order because this performance was so good and the quality was so high. So we got about another $10 million project, and we had already done all the homework in the setup ahead of time. So it was even more profitable to get that second round. So we've got some training coming up. If any of you are interested in it, reach out to me by email or give me a call. And when I send out your email following up from this training, from this webinar, I will give you some links to this training in case you're interested or would like to recommend it to your company or anything. So my services include training, assessments, coaching, and consulting. And I've got a really strong track record of getting results that are very similar to this. So if anyone is interested, just let me know. And